So after we subtract 6,000 from both sides, then this first part, we've undone it, so this first part goes away, right? And we're left with, let's see, here's my equal sign. Over here I have 0 minus 6,000, I get negative 6,000. Right, I have $0, I owe 6,000, altogether I owe 6,000. This side I have negative 750x, and then this part goes away, right, plus 0, that goes away. So this we can just cross out. Does everybody understand how we got this far? Yes, no? Check with neighbors, good? All right, so now we need to undo this. How do we undo multiply by negative 750? Divide by negative 750. Good?
Oh, you want to be positive.
No, it's negative. You're multiplying by negative 750. How do you undo multiply by negative 750? You divide by negative 750. The same thing, right? So we're going to divide by negative 750. And what do we get? Well, over here, this becomes 1, so you just have x. So everybody okay with that part? And then bust out your calculators and take, okay, so a negative divided by a negative is going to be what? Negative or positive?
Positive.
Positive. Okay, so then everyone gets 6,000 divided by 750 in your calculators. Bust them out. If you did it already. Phone is perfectly fine. David, what'd you get?
8.
Perfect. Jen, you get the same thing?
Yeah.
Great. So we get x is positive 8. All to 8. Let's call it 8. Good? So that is 8 what's? What's x again?
8 hours.
Hours. Yep, so 8 hours. That's how long it'll take the tank to become empty. Okay, the last question is the point 4, 3000 lies on the graph. It's on the graph. Explain its meaning. So, which one's my x, which one's my y? 4 or 3000, which one's x?
4.
4. X stands for what? Hours. So, at 4 hours, what's my y?
3,000 gallons.
3000, what's y stand for? Gallons of water. So I have, at 4 hours I have how many gallons of water? 3,000 gallons of water. Everyone write that down. Write down what this means. And I will ask, check with your neighbors. Write it down. Check with your neighbors. Right, because this is x. Right, so we should be clear. Remember, your x stands for hours. That's this one. My y stands for gallons of water. That's that one. Right? Is everybody good with this part? You need to keep that straight. So that means that, what does that mean? That means when after 4 hours, after 4 hours what? Someone help me out here.
The tank contains 3,000 gallons of water.
Yes, the tank, nice. Perfect. Thank you, Natalia. I appreciate your help with that. Perfect. Okay. Let's do another one. Oh, we already did that. We did that. Okay. Here's another one. Here's a scatter plot. Okay, so is this sort of like a line? Roughly a line? As opposed to like, you know, a big U-shaped or some of those other things, or like a swishy thing we've seen, right? So it could be a line. Is it more like a line, or is it more like a U? Or is it more like a swishy shape, like this sort of thing? Or is it more like a, we've had something that looks like this as well? Or is it more like a line? What do you guys think? It looks kind of like a line, right? I can sort of say, okay, it's kind of like a line. Do everyone kind of follow me? I mean, it definitely looks more like that pink line that looks like this, or like this, right? Everybody kind of understand what we're saying? So, life doesn't resemble, very rarely, does like perfectly match something. It does, like if I say something like, I go to the store, bakery, and muffins cost $3 each. So if I buy 0 muffins, I spend $0. If I buy 1 muffin, it's $3. 2 muffins, $6. 3 muffins, $9. That's a perfect line. But otherwise in life, things, if we're talking about percentage of people below the poverty line, that's never going to be exactly perfect, right? Life is messy like that a little bit, right? So what we do a lot of times, we use graphs to approximate life, situations in life. So we are saying, well, that's approximately linear. Why do we care about approximating them with graphs? Because then we can predict. And there's money in prediction. Right? If you can predict how a stock is going to go, if you can predict what is going to happen here, you can sort of try to do things to prevent it or change things or help things, predicting is one of the earliest ways that statistics is used to make people money, basically. Okay. So here, we say it looks sort of like a line. Okay, good deal. What is the trend? Upwards, downwards?
Downwards.
Yeah, downwards. Right, so it trends downwards. Trends down. Words. Okay? Okay. Now we're going to flip the page. Draw a straight line that comes close to as many points as possible. Can they model by an exact linear model? Okay, so here, I'm going to try, the first thing you want to try, is the hint, try taking it from the first point through the last point and see if that works out pretty well. That works out pretty good, right?
Yeah.
So that's our first choice, is to take the first point and the last point and see if that matches up. If for some reason the last point was wonky or the first point is wonky, like say the last point is really like down here. Oops. Yeah. Or if it was up here, then I wouldn't use it. Right? Is that everyone kind of following me?
Mm-hmm.
If the last point or the first point was really wonky, I wouldn't use it. I use the second to last point.
Mm-hmm.
Everybody understand what I'm saying? Likewise, if the first point is wonky, then I wouldn't use it either. So everyone see what's looking up? I'd use the second to last point. This one here, the second to last. So it's just sort of your first choice. I want you guys to use is the first and last points. If either of them is wonky, then use the next one over. Good? Yeah. Good. Oh, sorry. No worries. Okay. So we are going to ideally use the first and last points. Can we be modeled by an exact linear model? Is all these points exactly on there? No. They're close. Right? So it's not an exact linear model. Like I said, in life there's very few exact linear models. Unless you're buying things or stuff like that, or things are draining in it. Well, actually not true. Some things are. If it's a enclosed situation, then it can be exact. But if it's like data with people in the world, it's very rarely exact. Okay, so it's not an exact linear model. So no. Using the first and last points to construct a linear model, f equals mx plus b. So here's my first point, here's my last point. I think, so again, our x's should be time. Everybody with me? Everybody, are you guys all with me? Our x's should be time.
Mhm.
So I'm going to make this years after 1993. I'm going to make 1993 0, ground zero. Is everybody okay with that part? Why? Because this makes the math a whole lot easier. Because, oh, look, now I have, do I have my B? If I do this, do I know what my B is already? Everybody talk to your neighbors, find the B. If I make this x, if I make this 0.
Point 15. Yeah.
Well, that's all I understand.
Talk to your neighbors, talk to your neighbors. David, talk to your neighbor.
Okay. Yeah.
Kelly, Jenna, you guys got it? Do you know what the B is?
Okay.
So remember, the B is, it's your y-intercept. It's what y is when x is 0. So if I make this x 0, then all of a sudden, boom, 15.1, that's my B.
Mhm.
So that's kind of one of the advantages. This becomes my B. Good?
Mhm.
If I make that when x is 0. That makes that easier. Okay. So here, I know that, oops, I know that my B equals 15.1. And I'm going to take my 2 points. Don't pick any 2 points. Do not, hey guys, listen up, this is a common mistake. Do not take the first 2 points. Take the 2 points on the line that we drew, the first and the last points. Good?
Oh.
You can't just grab any 2 points. I drew a line from the first and the last through the first and the last points. That means I need to use the first and the last points to find my slope. Do you guys understand what I'm saying? I got to use this one, the first one and the last one. So my first point is what? 0, 15.1. What's my last point? And write down the x and y for the last point. Everyone write it down. And then check with your neighbors, confirm you have the same thing.
7, 11.13.
Callie, you got it? Jenny, you got it? The last point?
2000.
Alex, you got the last point?
11. This is the X1 level, Y1, and the next 2 Y2 or something?
Okay. All right. So,
Oh, yeah, like this, it was right in order like this. Yeah, Y1 is 2.
so 7, 11.3. That's my second point. Everybody on board with that part?
Mhm.
And my first point is 0, so this is 0, 15.1. This is 7, 11.3. Those are 2 points I'm going to use to find my slope. So what did I say? 0, 11.3?
Yeah.
No, 15.1. And 7,
11.6.
thank you. All right, so which way do you guys want to go? This way to that way? Do whichever you need to do. Find your slope. Find your slope. Take 1 minute, find your slope. At home, pause the video until you find your slope. So the beauty of this, guys, if you get used to doing this, is that you'll see that these ones are on top, these ones are on the bottom. So if you kind of remember to do this, do the back one, start with the back, and do the back first on top, and then you do the front on the bottom, then it helps you kind of remember that, oh yeah, this one's on top, the Y's are on top, the X's are on the bottom. So I think where you guys are all at is this. I think you're all at 11.3 minus 15.1 over 7 minus 0. Good. And what did you guys get? So you got negative, was it 3.8? Is that what you got?
Yeah.
Okay, 3.8 over 7. So you end up with negative 0.5, help me out, 5.4?
Yeah, 8.4.
Oh, 8.4?
Yeah, 842,105, yeah.
I got negative 0.542.
I'm going to go with that.
Right.
Divided by 7.
Oh,
Oh, because yeah, this one.
we did it wrong, we did 7 over.
Yeah.
It's Y over.
Ah.
Y
That's
over
fine,
Y.
yeah.
Right. No worries.
That's
That's
not
why we're doing it together in class.
The rise is Y, right? Okay.
Yeah.
Yep.
And the run is X.
Yep.
Okay, that's fine.
So that's why, guys, so heads up, if you guys get in the habit of writing them like this, and starting from the back one, and going forward on top, and then starting with this one and going downwards along the bottom, it kind of helps you because the top arrow is your top, the bottom arrow is your bottom. Does that make sense, what goes on the bottom? It just, if you get in that habit, then it makes it easier to kind of say, oh yeah, that's on top, this is on the bottom. So this top part divided by this bottom part. Okay,
There you go.
good. So now we have our M, right? And we have our B, so we can have, that's not our equation, then what's our equation? Everyone write down the equation, the actual equation. Construct the linear model. The linear model is y equals something with x in it. The linear model is y equals something with x in it.
B, and we just solve for what?
We just solved
Yeah.
for,
Yeah. So,
B would be the final.
what is that?
What does y equal?
Oh, so we just solve for M, okay.
You just did.
Yeah.
Our linear model is y equals nx plus b, filling in the m and the b. And is everyone on board?
For X?
Y equals.
X. Oh, you just put parentheses around X, or it doesn't work?
Okay, did you guys all get this as your answer?
How come?
That's
Yes? What was that?
Is that supposed to be on C?
The answer 2.1?
The M.
M is, this is my M? Oh, it's not negative, I'm sorry. Thank you, because I made a mistake again. Negative. There, yes, we do. All right, everybody good? Thank you. All right, this is what you guys have? This is our linear model. It's our model. Y equals something with x in it. When I say write an equation that models the situation, I mean I want something y equals something with x in it. And the rest of the things are numbers.
2. Oh, so you're going
Okay.
2 out.
Now, use your linear model to approximate the percentage of Americans living below the poverty line in 2010. So 2010, what's my x in 2010? Go back to your table, figure out what x would be in 2010. Everybody, flip back here. Okay guys, eyes up here. I need to figure out what x would be in 2010. So yeah, so 2000, it's 7. 2010 is 10 years later. 10 years later, we'll be adding 10 here, it means I add 10 here. 17. So, are you guys following what we're saying? So in 2010, my x is going to be 17. Just make it blue. is everybody all right with that? Does anyone know where we got that from?
Yeah.
Does anyone know where we got this from? Yes, yes, Alex, yes, David, yes, no? Okay, means this is 2000, 10 years later, it's 2010, 10 years later, 17. Okay, so that means x is 17. So find, when x is 17, find y. Everybody do it. And then take a look at E and see what you notice about E too. Do both those things. Everybody at home, do that, and then pause your video now, and then start when you have finished D and E. Take a look at this one. So x is 17. You guys put in 17 for x. So here's my formula. Y equals negative 0.542. I'm going to put a giant parentheses where x is, plus 15.1, and inside I'm going to put 17. You guys do that, you'll multiply 17 times negative 0.542, 8, 9 point something, so you should get something around 5 or 6 something. What do you guys get?
1.886.
886. So that would round to 5.886, 5.89.
Does it matter how many places we carry this out to, like on the?
Since the problem has only, the answer is mostly have one decimal place, we should probably round to just the same. So we would say 5.9. You good? Good? Okay. So, is everybody all right with that part? We good to be gone? Okay. So what do we see? Should have gone down, right? 5.9, but it didn't. All of a sudden, it turned around and started going back up again. Does everyone kind of see that? So, what happened? I guess bad stuff happened. Maybe Enron happened, I'm not sure exactly, but.
Like the .com bust or something?
Yeah, it was .com bust and all other stuff. All right, so we're gonna compare percentages. So what we're gonna do is we're gonna take what we expected to get, 5.9. We're gonna subtract the is the original amount. Okay, so we're gonna take what we actually got, subtract what we expected to get, and then divide by what we actually got to see the difference. So we'll see how far off it is. So how far off is it? It's 9.34, 9.4 away from what we expected to get. So it's a pretty big percentage. This kind of gives a percentage of the difference compared to the whole, which is like, I don't know, like 70%. And they do it?
94 over 153.
Mm-hmm. Do you see what she did? She did 94 over 153 because they both have one decimal place. She just moved over the decimal place on both of them.
There.
So it makes it easier. You can totally do that. What'd you get? 0.614?
Yeah. Also, it's the match.
I'm sorry. Thank you. Do you see what they did? They got, thank you. They got, they just took, so they both have one decimal place. They just moved them over and then they did 94 divided by 150.
Instead of doing that divided by that times 100.
Yeah, well, the thing is, with decimal places, you can, if you move both of them over, this is the same thing, because I'm multiplying by 10 over 10. If I multiply by 10 over 10, this becomes 94, this becomes 153. So it's kind of a nice trick. If you're totally, like, confused by that, then don't do it. But if you're like, oh, I kind of got the handle on this, then it's just a nice trick. If you feel comfortable doing it.
61
Okay,
Yeah, 61,
614? So that's a pretty big difference, 61% difference.
Oh, I didn't get that.
Okay. What events in, so yeah, so 2008, 2010, we also had like another little stock market crash, federal recession, so that was totally recession. Recession, totally killed us. But there's a dot-com thing, and there was all sorts of stuff going on all the way through all the stuff.
There's a really big computer and hardware thing going on. Then too.
There was tons of stuff.
A lot of hardware companies shutting down because this hardware and software wouldn't coincide together.
What was the answer for F?
What's that?
What was the answer for F?
The recession.
No, F.
Oh, 0.614. What was that? I don't know. You don't have to fill, you don't have to fill it in, that's okay.
614. That's all right.
Oh, sorry.
So that one.
Okay. So we're gonna take a look at interlinear regression is our next one. There we go. This one here. Alex, go ahead and read for me.
You have learned that when a quantity changes at a consistent rate over time, a linear model may be constructed given the appropriate information. Such linear models are very useful as they can be used to identify trends and to predict future behavior. In the real world, linear models are used in a variety of fields. They are based on actual data collected over time. A special technique known as linear regression may be used to develop a linear model based on data.
Perfect, thank you. So we're gonna kind of do this as a group together. So first introduction. How about, Fox, can you read the next part for us?
You would think that technological advances in the workplace have made it possible for us to work less and have more recreational time. Wrong. The bar graph below shows that an average number of hours that Americans work per week is gradually increasing.
Yep, see that? So as we kind of go along, the 80s, and then kind of late 80s, 90s, it went up more, and then 2000 went up more. So we're working more and more hours. So we're going to transfer that information from the bar graph to a table below. So X is the number of years after 1980. So in other words, this is 0. What would this be?
1.
Nope.
Oh,
80?
oh, 9.
9. So everyone with me? What's this one?
13.
So 1980 is 0. 1993, subtract 1980, 13. And I want to figure out what these two numbers are and write them in, find your X's, and then the Y's are written above. Can you guys see those in the top? So put them into this. Write them into that table below. At home, write them on the table below, and then pause until you do that, and then come back.